Hello, hello.
Hello.
Today we're gonna study chapter 20 and 21.
Oh, and what is chapter 20 about?
Chapter 20 is about environment, resources, and recycling.
Oh, fantastic. Very interesting topic.
So are you ready to study?
I am ready to study.
And Chuchi is ready too.
Wonderful.
In his dream. Okay then, let's move on to exercise 1.
Ooh. Very good. So we're going to click, click, click.
This is a grammar question, right?
Oh, that you're going to be speaking Korean later then.
That's right.
Oh, always exciting.
Are you ready?
I am ready.
Okay then. Here we go.
Each autumn, millions of salmon swim from the Pacific Ocean and head for the west coast of North America in search of a river mouth. Salmon don't swim upstream on just any river. They return to the same place where they were born. It makes sense that predators like eagles and bears eagerly await the return of the salmon each year. But the fish are just as important as a source of nutrition for the forests of the region. No, trees of the Pacific Northwest don't have teeth, but when fish are dragged out of the river and partially eaten by other animals, the remains to be left lying around on the ground. After they decay, nutrients are absorbed into the soil of the forest floor. There, roots from the great trees draw the nutrients upward, nourishing the trees. This is one of the reasons why the trees of the coastal regions of the Pacific Northwest get so big. Very interesting.
Yeah, so what is the story about?
Well, you wouldn't think of it, but how fish help trees grow.
Oh, how is that possible?
So animals hunt the fish, and then they bring them on shore, and they leave pieces of the fish behind, and that gets absorbed by the ground and then absorbed by the trees as nutrients.
So leftover fish can be a great nutrients for trees then, huh?
It can be great nutrition for them, yeah.
I see. All right then, it's time for grammar lesson. All right, here. So number 1, where is it? Here, number 1. So where의 밑줄에 쫙, where은 관계 부사인지 한번 볼까요? 자, 관계 부사 where일 때는 뒤에 완전한 문장이 옵니다. 맞죠? 그리고 선행사로 장소 나와 있습니다. 자, 뒤에 보니까 they were born. 아하, 수동태로서 완벽한 문장입니다. 그래서 where no problem. 그들이 태어난 똑같은 장소로 no problem, right? And number 2. important 밑줄짝, 형용사의 밑줄짝이네요. 형용사인지 부사인지 묻는 거겠죠. 자, as 사이 동등 비교에는 형용사도 올 수 있고 부사도 올 수 있습니다. 그럼 어떻게 하냐? 자, 여기만 보면 important로 되지 않나 이렇게 생각하십시오. 자, 그래서 전체적인 문장을 봐야됩니다. fish, 자, as가 없다고 생각하면 됩니다. 간단하게. fish are important. 아하. 보어로서 형용사 자리죠. 맞죠? 그렇기 때문에 fish are important. correct 합니다. as가 없다고 생각하면 쉽게 눈에 보입니다. 근데 fish인데 왜 are냐? fish는 단복시형이 같습니다. 그래서 fish are, a fish is 이렇게 됩니다. 오케이? And number 3. 3번은 to be의 밑줄이 쫙. 자, 이럴 때는 전체적 문장을 좀 구조를 봐줘야 됩니다. 자, but 이하부터 새로운 문장이 시작합니다. 종속절. when fish are dragged. fish가 drag 되어지고, 그리고 나서 eaten, 먹어졌을 때 by other animals. 자, 종속절 when 되고, 그럼 알아, 이게 수절이 되네요. the remains가 주어고, to be left lying around. 근데 동사가 없습니다. 동사가. lying이 동사가 될 수 없죠. 이건 ing니까. 아하, 그래서 동사 자리. the remains are left lying around on the ground. lying은 뭔가? 이거 수동태니까 그럼 우리 원형 능동태를 한번 생각해보면, 자, other animals들이 먹겠죠, 그 고기를. 그래서 other animals leave the remains lying around on the ground. 아하, leave는 오형식 쓸 수 있습니다. leave 목적어 목적보로서 ing가 온 거죠. 맞죠? 목적어로 목적보한 상태로 남겨두다. 그래서 the remains가 주로 빠지고 remains 복수니까 the remains are left, 나머지 먹다 남은 것이 남겨졌다. 뭐 한 상태로 lying around on the ground 한 상태로. 그래서 no problem, right? Okay, now number 4. no reasoning에 ing가 있네. 그럼 이거 전체적인 또 문장 구조로 봐야입니다. ing인지, pp형인지, 아니면 동사의 형태를 취해인지. 자, 여기서 보면 roots from the great trees, draw. draw 동사 나왔습니다. 그래서 roots가 draw한다. nutrients를 맞죠? 위쪽으로. 자, no reasoning, 영양분을 공급하다는 타동사입니다. 타동사인데 뒤에 the trees라는 목적어까지 있네요. 그러면 no reasoning 하면서 분사구문 no problem, right? 자, 그러면 넘버 5로 갈까요? get 동사의 밑줄 짝 있으면 이게 주어, 수일치를 찾는 문장이라고 했죠. 그럴 때는 주어, 핵심 주어를 찾아입니다. 바로 앞에 있는 게 절대 아니랬죠. 이때는 주어 좀 깁니다. 그래서 수식어고 다 버려버리고 trees, 나무는 나무인데 of 있는 나무, reason인데 of에 있는 reason 지역이 되겠죠. 아하, 여기서 핵심 주어는 the trees. 그러면 수일치 get 맞습니다. 맞죠? trees get so big. That's it.
Wow.
So the answer is number 3. You should change to be into are. Okay?
The remains are left lying around.
Exactly, right?
Very, very good.
Excellent. All right, then let's move on to exercise 2.
Very good.
Ooh, my. So this time we have to put the story in order.
Very good. We'll click. So we can discover what order we need. Oh, we get small.
All right, then. Are you ready?
So we have CBA.
That's the answer. Okay, then here we go.
Aviation experts are urging the more rapid introduction of more efficient jet engines that burn less fuel. This would reduce direct air pollution released per passenger mile. However, increased engine efficiency can have paradoxical results as far as global warming is concerned. More efficient engines produce exhaust with higher relative humidity, which can increase vapor trail formation. They also tend to produce more NOx, nitrogen oxide, because they burn fuel at higher temperatures and pressures. To significantly reduce aviation's contribution to global climate change, radically more efficient aircraft may be needed. One such design, the SAX-40, was unveiled by the Silent Aircraft Initiative of Cambridge University in the UK and the Massachusetts Institute of Technology in the US in 2006. The 215-passenger plane, still only a concept, featured a blended wing body design and efficient engines. Such designs, if successful, will also reduce noise pollution from aviation.
All right, then. What is the story about?
Well, they seem to be encountering problems of transitioning from older technology that used fossil fuels to modern technology that's better for the environment, and discovering that some of their alterations of these machines might lead to other problems in the environment. And so how to sort of troubleshoot, figure out these problems.
So they try to come up with the efficient jet engines, right? Burning less fuel, but it can also cause some problems, right? Other, environmental problems, right?
Yes, it says here more efficient engine produces more exhaust and a higher relative humidity, increasing vapor trail.
What is vapor trail formation?
When you look up in the sky and you see an airplane and the it looks like smoke.
Yeah, I've seen that. Yeah.
Yeah, and that's the vapor trail. It's called.
I guess it's bad for the environment then, eh?
Yeah, it's sort of a chemical residue, I think, and it gets into the atmosphere.
I see. So they needed a radical, more efficient aircraft, right? So which is SAX-40, right? So that one, it talks about 250 passenger plane. It's the same one, eh? Then.
Yes, exactly, and that's why we go from B to A. So it talks about this new airplane designed by these very important technological universities.
And also, C talks about the efficient jet engine, right? So C says, however, increase engine efficiency. So it starts with a C. And then move on to B. And then A, right? Because it talks about the same, the aircraft, 640, right?
Yeah.
And it features a blended wing body design. You can see the picture, actually. That's the blended wing body, huh?
Right down there. Look at that. It's a funny-looking airplane.
Yes, if it's successful, it also reduces noise pollution, huh?
It'll fly silently, or near silently, yes.
Wow, interesting, huh? All right, so we found the answer, C, B, A, right?
Very good.
All right, then, let's move on to exercise 3.
Very good. Ooh.
Ooh. So this one, we have to find incorrect word in context, okay?
Incorrect word in context. Very good.
All right, then, are you ready?
I am ready.
Okay, then, here we go.
Over the years, there has been a shift from develop now, and if there's a problem, seek abatement and clean up, to avoid problems if possible. There has also been a shift from the burden of problems being borne by those affected to its being handled by the public in general, or better still, to make the polluter pay. If forced to pay for errors, the polluter is hopefully less likely to solve problems. It is also more just that bystanders, consumers, or workers should not pay for developers' mistakes. In the past, penalties for pollution were often hard to enforce and were relatively light. Consequently, organizations motivated by profit would be tempted to push the envelope and try to get away with sometimes getting caught and paying limited damages. There's also a risk that licensing and penalties for infringements will have similar outcomes. In an ideal world, environmental managers educate and motivate potential polluters to seek genuinely to avoid polluting.
So what is the story about?
Well, it's about how to encourage, especially companies, to pollute less. And the problems they had in the past and some ideas for the current situation.
So in the past, they just develop first, right? To make a profit, So if there's a problem, they fix it, But now they try not to make any problems, right?
That's right. They try to make their product to avoid future environmental problems.
So the number one, so at first, before they change it, before the shift, those people who got affected, they have to pay for that, for the problems, right? And then it was changed, those polluters, the companies, they have to pay for it, right?
That's right.
So number one is correct, right? So there has been a shift. So in the beginning, from the burden of problems being borne by those affected, those who are affected, right? And then it changed to, those companies, they have to pay for that, right?
That's right. And that's why we have, if forced to pay for errors, the polluter is hopefully less likely to
cause problems.
Yeah, solve problems is not correct.
So if they have to pay for their errors, they will try not to cause any problems, right?
That's right, exactly.
Okay. So that's why number 2 is the answer. What about number 3? Tempted.
There it is. Tempted. Consequently, organizations motivated by profit would be tempted to push the envelope. Tempted means a desire. To push the envelope means how far they can go, the limit, right?
To push the limit kind of thing?
Push limit or make something happen. And so how far can I get away with something?
I see.
Right?
Because they want to make a profit, the companies, they're always tempted, right?
Yeah.
Okay, so that's why number 3 is correct. And what about number 4?
Risk. There is also a risk that licensing and penalties for infringements will have similar outcomes. So risk means a dangerous chance.
Yes.
And licensing penalties and infringement will have similar outcomes, that it won't work as it didn't work in the past. They tried to cheat the system.
Yes, there's a risk and danger, right?
Yeah.
So what about 5? Avoid.
Avoid. We have motivate potential polluters to seek genuinely to avoid polluting. We'd want that, and that's correct. Yeah.
Yeah, it's always like those companies. They try to avoid polluting, right? That's the best idea in an ideal world,
Yeah, and
So it's
that's
the best for them,
the shift that has happened. Yeah.
That's right. So number 5 is the correct, right, in context,
Very
so
good.
number 2, we have to replace serve with what? Cause, right?
That's right.
That's right. Okay, now let's move on to exercise 4.
Very good.
Wow. So number 4, we have to find the best topic for the text.
Okay. Oh my. Oh, we're getting very small.
Oh.
Let's move us over here at least.
All right then. So, are you ready?
I'm ready.
Okay, here we go then.
In 1783, Goethe wrote, "Nature is ever shaping new forms. What is, has never yet been. What has been, comes not again." If this is true, then the aims and objectives for nature reserves are for us to define as we see fit. It is now generally accepted that there is no default setting for how the world should look. Natural means different things to different people. For some research workers, natural states are those that existed before the Europeans turned up and started clearing land, farming, grazing, and controlling wildfires. This definition is being revised now by other researchers because humans have been altering the world for much longer than the Europeans have been colonizing the world. Furthermore, some human-induced changes are impossible to change. In addition, we must realize that environmental and ecological changes are normal. The world is in a permanent flux, and few of our present major ecosystems are more than 12,000 years old. Records from paleoecological studies seem to indicate that for any given place, over time, there are many alternative, very different natural states.
Wow. So what is the story about?
Well, it's saying that our view of what the natural environment of the planet is changing, because we used to see it from the perspective that humans have changed and altered what is natural. But they're saying that the planet is always in flux, always been changing, much before humans have been changing the planet.
I see.
And so we have to view the word natural from a different way, not just from the human perspective.
So nature is in a constant state of a change, right?
That's right, permanent flux.
Oh, I see. So it's hard to define what nature means then, eh?
That's right.
Oh, I see.
And that's why we have our answer. The variability, the different views of the definition of natural.
I see. So that's why number 2 is the answer, right?
That's right.
All right then, that's all, right?
Okay, so we're going to move on now.
Time for chapter 21.
Very good. And what is chapter 21 about?
Chapter 21 is about physics, chemistry, life sciences, and earth sciences.
Wonderful. All about the science.
It's all about science.
Oof.
So we have students to study science together. Here's a Stinkeroo.
And her father, Choo-Choo.
All right then. Time for exercise 1.
Here we go. Now, what do we have to do with exercise 1?
Exercise 1, we have to find the sentence in the box goes.
Okay, so we see it goes in number 5. So I'll read that into number 5.
That's right.
Okay, here we go. Viruses are indeed proving useful in several ways, thanks to their special ability to make their way into the interior of normal animal or plant cells. An example of this type of treatment is gene therapy. Sometimes a gene is faulty, and this fault can be passed on from one generation to the next. The main job of a gene is to act as code for the production of the proteins upon which every living thing relies. Proteins both provide structure for living tissues and drive chemical processes. If a gene doesn't carry precisely the right code, it may not be able to produce proteins normally. Gene therapy works by inserting a normal copy of the human gene in place of the faulty one. To achieve this, researchers have had to find ways to get the new healthy gene to the target cell without arousing the body's defenses, and once there, to penetrate its outer membrane to replace the defective gene.
Wow. So what is the story about?
It's about gene therapy. It's about how we fix faulty or broken genes in our body.
So we replace the faulty, defective genes with the normal genes.
That's right. And it's a tricky thing to do because when we try to put something into our body and change it, our body takes up defenses against that. So we have to sort of trick it into accepting the new gene to fix the problem.
So we use viruses to do that?
Well, it says they're proving useful because viruses, what they do is they get into our body, and if they're successful, they make us sick, right? And so they have passed through the defenses.
I see. So where does the sentence go?
Well, here we put it into number 5 because we have gene therapy works by inserting, okay? And so it explains the function or the process of gene therapy.
And also the next sentence starts with to achieve this. This refers to the inserting normal copy of the human genes in place of the 41, right?
That's right. Very good.
All right then. So that's why number 5 is the answer. We're gonna move on to exercise 2. Okay.
Ooh.
So we have to put them in order, right?
So it goes in the order BAC.
That's right.
Okay.
Okay.
The disciplines that make up the natural sciences can be divided into 2 classes. Those that are historical and those that are not. For subjects like cosmology, geology, and biology, history is of utmost importance. The goal of much of the activity in these disciplines is to reconstruct the history of the cosmos, the Earth, and the life forms that have inhabited it, respectively. For the mathematician, physicist, and chemist, on the other hand, history does not matter. The logical structures mathematicians explore are timeless, and both physics and chemistry deal with properties of the universe that we have every reason to believe are the same today as they have ever been or ever will be. Thus, in principle, all the open questions in physics and chemistry could be answered this afternoon if the right experiments were done. Moreover, there's no reason to think that the outcomes of those experiments would be any different if they were done by other people at other times or in other places. The assumption that the conclusions reached by physicists and chemists are independent of time and place is fundamental to the way geologists, biologists, and cosmologists use them. Very interesting.
So what is the story about then?
Well, it's saying that some parts of science deal with history, but other parts of science are timeless. Their function is always true. Regardless of whether the experiment is done in the past or the future, you'll get the same result.
I see. So we can divide the natural sciences into two categories, right? So one, the history is important, and the other one, the history is not that important, right? Because the result is always the same.
That's right. So for
which subject is important?
So
History is important.
important for history is cosmology, geology, and biology. And the reason for this is that what they study changes over time. So, for example, the universe is expanding. With time, it gets larger. Geology, planet Earth, the mountains erode. They get smaller.
Yeah, as time goes by.
As time goes by. And then for biology, there's evolution. Our bodies change over a great deal of time.
Right?
But for physics and chemistry and mathematics, their results are always the same, no matter when you do the experiment. So if cave people were able to understand modern physics and math and chemistry, they would have been able to get the same results from experiences as we do. And in the future, that will be the truth as well.
So mathematics, physics, and chemistry, they are timeless. They are independent of time and place, right?
That's right. They will be the same result no matter what.
I see. So first of all, let's find the answer. So the sentences in the box, it talks about what?
Well, it talks about the two classes, but then it mentions specifically the ones where history is important.
Some disciplines in this sentence, what does that mean? It's an academic field, eh?
Yeah, disciplines means fields.
I see.
Departments. Yeah.
So B talks about the goal of most of the activity in these disciplines, right? So it can be a big hint, right?
And so we have cosmology, cosmos, geology, Earth, and life forms is biology. So they match perfectly.
That's right. And then at the end, it talks about the subject that the history does not matter, right? So, and then A, mathematics, they talk about.
That's right.
It's timeless, blah, blah, blah.
Yeah.
Right?
And so they mention mathematician, physicist, and chemist, and then mathematicians explore physics and chemistry. So that connects very well.
And also whoever experiments it, the result can be the same, right? So they can be answered this afternoon if the right experiments were done. And C says, moreover, the outcome of these experiments could be, it cannot be different, right? It's always the same. Whoever experiment it and wherever you do it, right? Whatever you do it.
And that's why these sciences that deal with history find the results of physics, mathematics, and biology, and chemistry so useful because they can work in the history as well.
That's right. That's why the last sentence, that's what that means, right? Can you explain again? The last sentence, sentence A, the assumption, blah, blah, blah.
The assumption that the conclusion reached by physicists and chemists are independent of time and place is fundamental to the way geologists, biologists, and cosmologists use them. So they use these experimental results as a tool in their own research because they know that the results would have been the same if they look back all the way to the beginning of time.
I see. So geologists, biologists, and cosmologists, they can take advantage of the result of those experiments, right?
That's right. So, for example, a geologist can use chemistry about the erosion of rocks and look at a rock today and imagine that rock 1 million years ago. The experiment will still be the same.
Oh, I see. Interesting, eh? All right, then. So the answer is B, A, C. We're going to move on to exercise 3.
Very good.
Okay.
Ooh.
So we have to find the best title.
Oh, the best title. And we're looking at space, the universe, and everything.
So are you ready?
Okay, I'm ready.
Okay, then here we go.
In the first minutes of its existence, the universe cooled so rapidly that it was impossible to manufacture elements heavier or more complex than hydrogen, helium, and, in minute amounts, lithium. In the heat and chaos of the early universe, nothing more complex could survive. From a chemical point of view, the early universe was very simple. Far too simple to create complex objects such as our Earth or the living organisms that inhabit it. The first stars and galaxies were constructed from little more than hydrogen and helium, but they were a sign of our universe's astonishing capacity to build complex objects from simple building blocks. Once created, stars laid the foundations for even more complex entities, including living organisms, because in their fiery cores they practiced an alchemy that turned hydrogen and helium into all the other elements.
Ooh.
Wow.
So what is the story about?
It's about the creation of the universe from its very simple chemical beginning to its now super complex makeup.
So they made complex ones out of simple ones, kind of.
That's right. So the first three things it made was hydrogen, helium, and lithium. And from those it mixed and became more elements to create complex objects. It mentions the Earth and living organisms like us and kitty cats.
So at the beginning, when the universe was born, it was quite simple, stuff, right? Elements, and then now there are lots of complex, elements, right?
That's right. And it says that it had to be simple at the beginning because it was a chaotic atmosphere, environment.
Yeah, it cooled down so rapidly, so they cannot make any complex ones. Eh?
Yeah, only certain elements could survive the creation of the universe.
Yeah. Okay, so that's why the answer is what?
The birth and development of the universe. Simple to complex. It's a perfect title.
That's right. How the universe was born, and also how the universe make the complex elements, right?
That's
out
right.
of simple elements.
And that's why number one is not quite correct. Wonders of the galaxies and the simplicity of the Earth. It talks about the simplicity at the beginning of the universe, not about Earth.
And also it does not talk about wonders. What about number two?
Hydrogen and helium, abundant elements in the universe, while true, is not only about that.
Yeah, that's right. It's not all about hydrogen and helium. Right? At the beginning, they had hydrogen and helium, right?
Yes.
And then what about number three?
How could early living organisms have survived on Earth?
They didn't talk about how they survived.
Yeah, nothing about that.
What about number five?
Heavy and complex elements, foundations of a chaotic universe. It does talk about that, but this title leaves out all the development and the important aspect of this.
Yeah,
of this
the
text.
foundation of the chaotic universe is like a simple elements, isn't it?
Yes, and that's why it's also not correct. Yes, you're right.
I see. All right, then let's move on to the last one. Exercise 4.
Ooh, here we go.
Oh, we have to fill in the blank.
Oh my.
Wow. Oh, wow, it moves. The Earth. Can you see that?
Oh, and one of the earlier ones moved too. The DNA was moving
Can
too.
you move a little bit? I want to say that.
Oh.
You have to click maybe. Ooh.
Wow, we like this.
Okay.
This PPT is made by.
Sam.
Thank you.
All right then. Are you ready?
I'm ready.
Okay then. Here we go.
The ancestors of all species that are alive today have flowed back and forth across the globe for many millions of years. We should never assume that where we see a species today is where that creature's ancestors originated. Modern humans resided in Africa 200,000 years ago and subsequently spread across the world. Yet most of us alive today think of ourselves as natives of the regions where we were born, rather than of Africa. When we trace our ancestry, we often focus our attention a few generations back, seeking a sense of place and personal identity. But these past places were also transient locations, and each ancestor transient, as our genes have moved around the planet's surface. It was ever thus. It is completely illogical, then, to hate a fellow human or another animal or plant simply because they or their ancestors were somewhere else at a particular time. The location of those genes in one specific time frame has no special meaning in the history of life.
So what is the story about?
Well, it's saying that forever, on the history of the planet, all species have been migrating around the planet, and that it's not logical to dislike a species that comes from a different place on the planet because our genes came from there too.
It says we are all from Africa or something.
Yeah. So a long time ago, the human species originated from one area and then migrated all across the globe, and that's why we now look different, because we spent a lot of time and evolved under different environments.
So we have the same ancestors, right, basically.
That's right.
So we cannot hate anyone because they are from different areas, eh?
That's
'Cause
right.
we do have the same, ancestors. We are from the same place,
That's right.
So that's why the answer is what?
Number 2 has no special meaning in the history of life. So the location of those genes, the location of those species or people, has no special meaning in the history of life.
Yeah, because the place they're living in is like kind of a transient location, they said, right?
Yeah.
It means temporarily. They live there,
That's right.
But the beginning, we all from the same place. Eh?
Yes.
So that's why, where you're from right now doesn't mean anything.
True. Yes.
Okay, wow, that's it, eh?
That is it.
All right, then, that's all for today, right?
We did a great job. You did a great job, students.
Good job. Did you learn a lot about science? Thank you.
I learned about science. That was very interesting.
All right, then. Time to say goodbye.
Take care.
Take care.